Let us discuss derivative formulas for Newton's backward interpolation formula. We have backward interpolation formula given by f of a minus nh equals f of a minus n times del f of a plus n square minus n by 2 factorial del square f of a minus n cube minus 3n square plus 2n by 3 factorial del cube f of a plus etc. Let us call this as equation 1. When you take derivative on both sides of equation 1 with respect to variable n, we will get LHS f dash of a minus nh multiplied to minus h, which is the coefficient of n which appears inside the function f, and we have RHS becoming minus del f of a plus 2n minus 1 by 2 del square f of a minus 3n square minus 6n plus 2 by 3 factorial del cube f of a plus etc. We have f of a is just a constant and derivative of f of a with respect to n will be 0. When you divide both sides of equation 2 using minus h, we will get f dash of a minus nh equals 1 by h del f of a minus 2n minus 1 by 2 del square f of a plus 3n square minus 6n plus 2 by 3 factorial del cube f of a minus etc. Here, when you consider the special case n equals 0, we have this second term becoming minus into minus 1 by 2 multiplied to del square f of a, which becomes del square f of a by 2. And we have at n equals 0, this term becomes 2 by 3 factorial multiplied to del cube f of a, which can be written as del cube f of a divided by 3. At n equals 0, we have the LHS becoming f dash of a. Thus, at n equals 0, we have this equation becoming f dash of a equals 1 by h times del f of a plus del square f of a by 2 plus del cube f of a by 3 plus del raised to 4 f of a by 4 plus etc. Let us now evaluate second derivative of Newton's backward interpolation formula. It's enough to take derivative of equation 2 with respect to n on both sides. Thus, we have LHS becoming f double dash a minus nh multiplied to minus h into minus h, which becomes f double dash a minus nh multiplied to h square. Taking derivative of RHS of equation 2 with respect to n, we will obtain 2 by 2 del square f of a minus 6n minus 6 upon 3 factorial del cube f of a plus etc. When you divide both sides of this equation using h square, you will get f double dash a minus nh equals 1 by h square times del square f of a minus n minus 1 del cube f of a plus etc. We have rewritten 2 by 2 as 1 here. We have for the second term 3 factorial is 6 and 6 can be taken common outside from numerator. Thus, we have second term becoming minus n minus 1 times del cube f of a. Now let us consider special case n equals 0, so that equation 3 becomes f double dash of a equals 1 by h square times del square f of a plus del cube f of a plus 11 by 12 del raised to 4 f of a plus etc. We have equation 3 becomes at n equals 0, f double dash of a equals 1 by h square times del square f of a plus del cube f of a plus 11 by 12 del raised to 4 f of a plus 5 by 6 del raised to 5 f of a plus etc.